Hi all. Today we're going to look at volumes and capacities, and we're going to just talk a little bit about, given a set of values, how could I find another value, whether that's a volume or a capacity? We're going to look at that. So what I'd encourage you to do, and when you get your homework, is to have in front of you, print out, make sure it's in front of you, the spirogram so that you see all the volumes and all the capacities. So that will give you a view of being able to look at items. Now here you can see that I've listed a set of values here. And so we have vital capacity, tidal volume, functional residual capacity, and residual volume. Now, what I also want you to notice is that I've given these to you in two different units of measure. I've given it to you in liters, and I've also given other values in milliliters. Okay. So I would say first off, step one is just to make sure that you're in the same unit of measure before you start plugging numbers in. So that's always important, okay? And so it doesn't matter whether you go from milliliters or liters. I'm going to, just to make it simplified, I'm going to switch all of these to liters. So I'm going to stay in the liter mode, which means I'll leave these two numbers the way that they're expressed, but I'm going to change the milliliters. And so I'm going to remove my unit of measure from milliliters and switch these over to liters, okay? And so again, in milliliters, the decimal points are here, and to switch it from milliliters to liters, I would move my decimal point by 1,000 or over 3. So 1, 2, 3, and so it's 2.4 liters here, and 1, 2, 3, 0.7 liters here. Okay, so now I have all of my units of measure the same. Now I can figure out what it is I need to do. Black. 2.40, 2.70. And again, just notice I have all of these to the decimal point that or the rounding that I want, so to the 100, okay? Now, if you have a number that's actually bigger, let's assume this was 0.703 ultimately, then I might not round it off yet until I get to my final answer, and I might leave it at 0.703 for now, and that's okay. Rounding off less is better than rounding off too much at the beginning, okay? So now let's assume that I want to find out ERV, reserve volume, is based on these values. So what I need to know is, well, where are these values? And so if I look at my capacities, I see functional residual capacity here. I see that my vital capacity is here. I see that my tidal volume is here, and I see that my residual volume is here. Now I've got to figure out, just looking at all of these, how could I build an equation? Because I don't have ERV here, but ERV is somehow contained within these values, and I could either put them together or subtract from each other to do this. So let's see. A capacity is a combination, I'll take vital capacity first, is a combination of lots of volumes. And so if I look at vital capacity and then I come over here, I see that it's a combination of inspiratory reserve volume, tidal volume, and expiratory reserve volume. Okay, well, that doesn't get me expiratory reserve volume quite yet, right? Or maybe it does. So if I take this here, and if I want to get expiratory reserve volume, let me see what I might do. I want to isolate expiratory reserve volume. And could I do that by taking vital capacity and subtracting tidal volume? Now, if I subtract tidal volume from there, that doesn't get me what I want because it's still inspiratory reserve volume and expiratory reserve volume. And it doesn't isolate that. So that doesn't work. Now let me look at FRC. Here's FRC, and it's a combination of expiratory reserve volume and residual volume. Oh, okay. So maybe if I took functional residual capacity and based on these values, I subtracted something, a functional residual volume and vital capacity. Really, you can't subtract from them equally because they're different parts of the total lung capacity. But if I take functional residual volume and subtract out tidal volume, well, if I look at this, tidal volume is not a part of functional residual capacity, so I can't do that. But what if I was to take functional residual capacity and subtract residual volume? Let me see if that works. FRC minus the RV part leaves me with the ERV part. So there's my equation. So now I can plug in the numbers, and I have FRC, which is 2.4 liters, minus RV, which is 1.3, zeros there, 1.3 liters, and 2.4 minus 1.3 gives me 1.1 liters. And so I have just figured out what my ERV is from here, okay? Now I'm gonna give you a couple of problem sets that you can practice for homework, and then of course this would be on the test in terms of you getting a set of values and then being able to find out what that is. So again, always great to have this printed out so you can look at it and explore. You will have a set of values, volumes, and capacities, and then you will be asked to identify a volume or capacity based on these values, okay? So once you have the values, first step is to make sure that all these values are in the same unit of measure before you plug them in. Then figure out how to build the equation. In this case, you built the equation by taking a capacity and subtracting a volume to get another volume. Now, what if I wanted to figure out total lung capacity? Well, let me see. Here's total lung capacity. Here are all the values I have. What values could I use to build the total lung capacity? Well, FRC. What about if I did FRC and vital capacity? Here's vital capacity and here's FRC. Well, can't do that because we're double counting the expiratory reserve volume. So I couldn't do that because I would be adding too much to that, okay? So it over exceeds the total lung capacity. What if I did the vital capacity? And here is vital capacity over here. And it looks like all I'm missing is the residual volume. Oh, there it is. So I could make the equation by adding vital capacity and residual volume to get the total lung capacity, and so on and so forth. So you'll get a chance to practice and look at those pieces. All right, thank you.